once again, thanks for coming out to New Game. It's awesome to be up here giving a talk about a really exciting project to everybody. So this is kind of a general post-mortem, a little bit of technical stuff, a little bit of production stuff, a little bit of business stuff about our project that we did in conjunction with Gradient Studios and Subatomic Studios, Fieldrunners HTML5. So just to give you a little background, I'm sort of a game developer in a web world. I woke up one morning and I was surrounded by the web, and I needed to do something about it. I'm a programmer at Bocoup in Boston. Previously, I was working in Facebook games at Blue Fang. I ran a gAnalytics middleware company called Orbis Gameworks for several years. And before that, I worked with our previous speaker, Justin Quimby, at Turbine on MMORPGs. So I've been in the traditional game industry for a number of years now. And so I'm trying to bring some of that knowledge into the web and to web developers and that sort of thing. That's kind of my personal goal and really why I work at Bocoup. So Fieldrunners, how many of you played this when it came out on the iPhone? Okay, some hands. How many of you have played it on any of its numerous platform releases at all, including the most recent one? Okay, a bunch more. This was essentially a launch title for the iTunes App Store. It was released in 2008 by Subatomic Studios. They're based in Boston. The App Store debuted just a few months before that. It was one of the first big hit iOS games. It was heavily promoted by Apple. It was extremely high quality and fidelity compared to most iPhone games, especially in that sort of first generation. This is a screenshot from the original version or at least a version of the iPhone Fieldrunners. People said things about it like, while there exist other tower defense games in the App Store, none carry this level of graphics quality and overall polish. And it's been ported to Nintendo DSi, PSP, PS3, Android, and now HTML5. So there's quite a legacy of quality for this title. And when Bocoup was contacted by Subatomic back in the spring to bring the game to HTML5 and the Chrome Web Store, we were very cognizant of that sort of quality legacy. One of the first things we did was we recruited Gradient Studios to work with us, another Boston local studio, to help add some programming power. And we started work in July 2011. This was a port. So the game was written in C++ and OpenGL ES2 for the iPhone, and we were porting it to C++ and WebGL. The overall stats for the project, it was 12 weeks of sort of production for the actual porting. That includes adding monetization and that sort of thing. There was about 3 weeks of pre-production and some testing in there as well. It was basically one programmer at Gradient, one producer at Bocoup, me, and Subatomic had some QA and a producer on their end as well. So 2 producers, 1 programmer. That was really fun for Z, right? He's in the audience, yeah. There was also new content brought into this build. It wasn't a straight port. We got new maps and towers and that sort of thing. But it was pretty hands-off. It was basically, hey, Bocoup, we've got new stuff in the repo. Sync it and port it. Okay. Technologies used in this, obviously WebGL. We used Web Audio API for audio, and I'll go into a little bit more about decisions behind that. We also used HTML5 audio. We used Google In-App Purchases API for the in-app purchases. JavaScript, duh. We used Python as sort of like the general purpose scripting language. And we actually used Go, about 500 lines of Go for the server-side stuff, for file serving, postbacks, and permissions. Basically everything around those in-app purchases to make sure that you can't just get access to maps you didn't pay for and that kind of thing. Mostly security around serving that sort of content. So our target platforms, we targeted Chrome and the Chrome Web Store as distribution. That's it. I'm going to come back a little bit to the decision making behind this. A big part of the decision process was that we weren't going to go for mobile because Fieldrunners already had great penetration in the mobile market through its native apps. And then we had various reasons for targeting Chrome as the only desktop browser as well, which I'll go into towards the end of the presentation. I want to talk a little bit about the plan of attack for this sort of thing in case you decide to take on a project of similar scope. Like I said, we originally planned, this is going to be an 8-week plan. It ended up being a 12-week job, so, schedules slip. So milestone 1 was just pre-production, and, technical design doc, all that stuff. We also did a lot of research into min-spec hardware. We kind of had one of those early CR48 Chromebooks that isn't that great hardware-wise, and we sort of just tested to see if it would sort of work on that. And we ended up coming up with a min-spec. We got the pipeline in place, and just did a bunch of production risk assessment as well. This only took a week. It was on time. Second milestone was our first 2 weeks of production. This was literally just, okay, dive into the C++ to JavaScript conversion. We tackled initial graphics logic, initial art integration, initial tower functionality in this 2-week period, and we pushed out a lot of proofs of concept and prototypes during this period. The particle system was particularly high risk. We had no clue whether the particle system would destroy people's frame rates until we actually built it. We did as best we could to estimate that, but in the end, we did some kind of cool tricks to sort of help us collect data on that sort of thing, and I'll go into that as well. Milestone 3 was another 2-week milestone. It was basically just, okay, finish the game now. And this was the part that was a little bit optimistic. We took 3 weeks on this one instead of 2 weeks, along with some optimization stuff that happened. And then our last milestone was integrating monetization, and that was also a 2-week milestone that took 3 weeks. So that was integrating in-app purchases, and the monetization content was ready to go, but we still had to sort of configure the menus and make it work that way, and that always takes longer than you expect. So I'll talk a little bit about the order of porting the systems. We knew this was a really aggressive project, so we had to make sure that we got all the really crucial high-risk stuff out of the way first. The absolute first steps were just getting stuff rendering to the screen, but not just rendering like, oh, hey, we rendered an image file. We had to parse the animation files, which were like a native format that Subatomic used internally, load the images based off of the animation files we parsed, and then render to WebGL in an asynchronous fashion. This was our entire first week of production, and we ended up producing this sprite demo here. So I'm going to load that up. Hopefully this works. There it is. So this was just our first, hey, we can load in all the different animations here. There's level 3 idle, there's level 1 attacking animation, that sort of thing. And hey, we can get the other towers in here too. The units are sort of hypnotic to look at. When that one loads, just pretend you're commanding an army. And then I like this one the best. That's the electric shock death animation. So the fact that we were able to get this up and running in a week, it wasn't so much that we got this demo in particular up and running, but the fact that we managed to do it the proper way by loading all the assets correctly the way through the pipeline that was pre-established by Subatomic. That gave us a lot of hope. That was sort of the first beacon of, hey, we can maybe get this done on time. Next, in terms of porting the systems, was basic tower functionality. Since this is a tower defense game where you're placing down towers and trying to, kill little dudes who are walking across the screen, we really wanted to make sure the tower worked. And we ended up porting the generic entity class, the tower class, and the projectile class to get this together. We ported most, but not all of the particle system for this as well. The particle system, there was a base particle system and then like a super particle system that had crazy special effects. And we did the base one for this milestone, which we knew we could do that one. The crazy particle system was a little bit more of a risk, and we understood that. And so this led to another demo, and this is actually our deliverable for that first production milestone, was this tower demo. Let me switch to the Gatling gun here. And we hadn't written great preloading code or anything like that either, so it takes a little while for stuff to pop up. But, you know, we had the tower capable of pointing at things and running its correct animations, and it ran at the right speed. And I think they even had the correct range of fire, so the mouse had to be just as close as an enemy would in order for it to work out. And we ended up doing, you know, stuff like that to test performance. Let me bring it back down to 1 by 1. And we were particularly interested in the performance of the flame tower. The way that Fieldrunners is designed, this is kind of a classic game developer trick where your most awesome units cost a lot of money within the game, right? And that makes sense within the fiction of the game, but it also helps you mitigate performance issues because it means you're only going to have 1 or 2 of those super awesome units on the screen at once, so you're not going to have too many crazy particle effects flying all around. The flame unit is kind of unique in Fieldrunners in that it does have a lot of crazy particle effects, but it doesn't cost very much in the grand scheme of things. So you could conceivably have a lot of these on the screen at one time. This is sort of the base effect for it. We're looking at like a little frame rate up there. It's running at 30 while the flame's going. And I'll make this 4 by 4. And so we started testing, you know, performance and seeing, you know, like, okay, it drops down to 20, but that's an awful lot of flame towers. They're probably not all going to trigger at the same time. You know, we can make it really just cry. Just so, you know, oh yeah, all right, that kills the frame rate. But all right, so this was a cool internal demo. Subatomic was very impressed with it. They were like, oh, we can actually, you know, now draw a line from this in our head to the final project, the final product, where the game is actually working. And that was great for us, but one of the issues was we still had no idea. We didn't have a giant fleet of computers to test this on. We didn't have you know, a huge QA department, that sort of thing. So it still didn't really answer our question of what is performance of the particle system going to be like. Enter the Fieldrunners WebGL graphics demo. This was an idea I had, which was where we just took our demo, packaged it up, sanitized it of all the content that Subatomic didn't want people to see because it was currently in development, and posted it on our blog. And we just said, hey, check out this cool WebGL tech demo. Everybody go and play it and just have fun with all sorts of different configurations. All right, that's all well and good, but being a person whose background is in analytics, I was like, hey, let's drop some analytics in there. So we ended up using the Google Analytics event API, which if you haven't used, I'm sure almost all of you have used Google Analytics, but it actually has an event API built into it where you can send essentially arbitrary data and it gets attached to a user profile, which is super helpful. So this is like our little code right here within our frame counter. What this is doing is it's just averaging the frame rate sort of over every 8 frames, and then every 8th frame it gives you sort of the moving average of window of the frame rate for the past 8 frames of performance. And you can see that what I'm sending in there, if I have a mouse here, yeah, so I'm just saying, oh, it's a Fieldrunners WebGL event. You know, we're sending in this ops.sprite thing, which is actually the name of the tower that they're rendering. And then all these options just are the number of rows, columns, just everything that was built into that form in the demo. And then sending in the actual frame rate over the last few frames. So we got some cool stuff. Like we could look at the overall view here and we go, oh, for the flame tower in Chrome, people were averaging over all their tests at 52 frames per second. And in Firefox, it was 54. And in Safari, it was 58. OK, that's neat. Let's break it down a little more. And we could break it down all the way to the point where you could get graphs like this, where we could compare Firefox and Chrome performance across all 4x4 arrays of flame towers, lightning towers, Gatling towers. This was sort of interesting to look at. I think we actually found a bug in the way we were handling some things where we managed to get that Firefox performance back up over here. You know, the important thing here was that everything was above 30 on the average over here, which was our target frame rate for this game. That's what it runs on all devices, and that's how the game timing is built around having a 30 frame per second game. So We got some other results as well, just looking at operating systems. You see Chrome OS down here. The reason that Chrome OS is all the way down here is because I believe the build of Chromium that was on Chrome OS at the time actually capped its request animation frame at like 30 frames per second, I believe. Don't quote me on that, but I think that's what caused that there. So anyway, again, we were just generally pleased with the frame rates across all operating systems. And again, everything's above 30 here, right? This is 4x4 flame tower arrays in Firefox through different Firefox versions. And as a stats nerd, I was able to get my box and whisker plots so I could look at quartiles and stuff, and I saw that Firefox had more variance, but it performed better on the top end. Chrome had less variance, and they both averaged about the same performance. So this was just a really helpful benchmark to make us, it sort of really energized the team. It got the whole, like, it felt like a good chunk of the web was buzzing about the game because they got to play with this cool effects demo, and we harvested an awful lot of data off of this demo. So that was extremely helpful to us and really good for team morale. So back to porting the systems. Next up was maps and enemies. Now that we had a tower working, it was time to get towers, little dudes for the towers to shoot. Maps and enemies didn't take that long to port relative to the towers, since they're actually less complicated. The AI wasn't that, there's actually a pretty good pathing AI in Fieldrunners, but that wasn't that bad to port because it's all just straight math. We didn't really have to bother with, it was pretty straightforward. Menus were so much work for you people who have never made a full game that has to have all the menus you need and stuff like that. This was just, the majority of the time during this chunk of work was spent making sure all the menus were in place and loading correctly and so forth. Just be warned, if you ever make a production game, you're going to spend a lot of time on menus. We heard a little bit about that sort of user experience stuff from Justin earlier as well. All right, at this point we were done. Now that was just done porting all the core systems. We still had to add monetization and other stuff. At this point in the project, total lines of code ported was 24,596. Total porting time, actually this says 8 weeks. It's probably more like 10 weeks porting time of one programmer. Again, he's the guy in the hat over there. You can all rush him for an autograph later. This includes fixing almost all of the functionality bugs in the game. The game was pretty much bug-free in terms of gameplay. There were still plenty of like browser bugs and that sort of thing that had to be squashed, and stuff through monetization and all that. But after porting all those different chunks of the systems, a lot of the work was just making it feel webby, making it responsive. We added the SD and HD mode where we scaled the canvas. We didn't use CSS scaling. We actually changed the canvas height and width to scale. Detecting WebGL, detecting web audio, detecting window size, making it generally responsive. That was a lot of work. I'm still not 100% convinced that we have a foolproof WebGL detection algorithm in there. We catch most of the cases, but I would not be surprised if someone came up to me after this presentation and said, hey, I got a black screen, and when I looked at the console, it was because WebGL wasn't finding a WebGL context. And so I would love to see a super robust WebGL capability detector out there. Another really big chunk of work was just hosting and like server-side stuff like configuring caching. Just figuring out hosting, it was partly an issue. I mean, we were using Google App Engine for hosting, which is great, and I'm going to show you some charts in a second. But just getting to that point where we had to figure out exactly where we were going to host and what the rationale was and what the cost was going to be and that sort of thing. It was kind of a big political thing to figure out. And also the fact that we were working with Subatomic, which are an awesome game development studio, but really don't have much web expertise at all. But they were supposed to handle the hosting, so it was kind of like, okay, we're going to put this hosting plan together, we're going to give it to you, you're going to come back to us and say we don't understand what this is. So we ended up writing a lot of tutorials for them to make it happen, which is fine, and we had to do that, but we hadn't really planned for that level of work and that level of friction. It's just weird to see the game dev and web dev worlds collide and what weird sparks fly when that happens. A note on caching. these are some charts from App Engine. On the top here, that red line is cached requests, and right before this big red line here was before we really turned on any significant caching. And you can see our CPU usage was super, super high. And then we turned on caching, and all of a sudden, everything was pretty cool, and we get tons and tons of cache requests now and not as many dynamic requests. It was just like, we basically forgot to launch with proper caching. And when we did launch, we looked at the numbers on sort of the ops numbers, and our heads started spinning, and it was like, okay, time to sit down and drop every other bug that we're trying to fix and get the caching set up correctly. So that was huge. That was basically 2 full days after we launched, was sort of making sure that we got that whole thing right. A couple notes on going from C++ to JavaScript. So we didn't use, it was maybe 70% of machine port. So we zeroed his own Python script to do the machine port. It's just a mess of regular expressions, but it got the job done. It did 70% of the work. It worked mostly within the functional scope, but not outside of functions. So we had to manually make sure all the class structures worked and were interpreted correctly and so forth. We used John Ressig's class, if you're familiar with that. It's like a blog post he did a few years ago. Oops, whoa, I just went all the way to the end of my presentation. Here's an example of some of the simpler rendering code that we had in the game, and I really wanted to show, this is in C, obviously, and this is in JavaScript, and you can kind of see that they're pretty much the same thing. The only thing I highlighted in blue down there was you get the nice overloaded operators in C, so you can just multiply 2 matrices together, and in JavaScript you had to call a function and pass it your 2 operands. So that's basically the only major difference here, I think. The more complicated rendering code was there were more differences, but it really wasn't that crazy. Some words on audio. We ended up going with the Web Audio API for sound effects. Now, we knew it would be released with Chrome 14, I believe, and we knew we would be launching after Chrome 14 came out. So working with Google and making sure that all the schedules lined up correctly, that was a big relief. The fact that Chrome auto updates, we could just kind of say, okay, basically everybody with Chrome will have Web Audio API when we launch. Great. We ended up using HTML5 audio for background music, just the plain old audio tag, because really that's what it's good for, and it meant that if for some reason someone didn't have Web Audio API, at least they'd get some background music. And I think that worked out super well for us. But again, this strategy was only possible because we targeted Chrome and Chrome Web Store. And as I think has been said a couple times earlier today, I just think audio is such an important part of a game experience, and we really, a big part of just being on Chrome for us was being able to use this Web Audio API and getting some fantastic sound. I'm going to take a break here to demo the game so you can see the graphics and audio in action. Well, hear the audio, but yeah, thanks, Flame Towers. Okay, so this is live, Fieldrunners, html5.appspot.com. Don't all rush out there at once. And I'll resume my old map. Let me see if I can, I'll change the audio when it gets, hopefully this isn't too, I had the music off so it won't be too loud. So this is the game. We can scale between HD and SD. HD is way too big for this projector, so I'm going to go back to SD here. So you can hear the sound. So we got lots of channels of sound playing, at the same time. They're all triggering with the animations correctly. When we see an explosion, we really want that sound to line up exactly when the explosion triggers. And it just works. It works like Fmod works. So that was really nice from an audio standpoint for us to have. Let's speed that up a little bit. Maybe get some more people in there. And it's got all the UI trappings of the original game in there. Oh no, they're gonna get away. Yeah, that's too bad. I can show some of the menus. So, it just works like a regular game. Options menu. We get a little brief loading screen in there while we load the assets for that particular options menu. Can bring the music up a little. Gets annoying after a little while. So, oh, that's loud. Yeah, we've got scroll wheel is detected and zooms if yeah, there we go. Yeah, that we're really happy with how it's worked out. I think the graphics are great. If I had more time, I'd build up a giant map and show you some of the cool particle effects for like the nuclear explosions. But I guess you'll just have to play the game and figure that out for yourself. So yeah, we were just really happy with the quality in the end. Some technical notes. We're going to cover some stuff about ArrayBuffer, JavaScript Scope, fault-tolerant loading, and running functions on unloaded assets. This is all stuff that we sort of found out in the process of doing the port. I highly recommend using ArrayBuffer Views to pack data for WebGL. Maybe you already knew this, but we certainly didn't. And it's just a great way to do things like position and color, for example. So this is an example of setting up an array buffer. It's 16 bytes. So we're gonna say, okay, 3 floats out of those 16 bytes are gonna hold position, and then 4 bytes are gonna hold color. So okay, here's our position, and that's gonna be a float 32 array, and we pass it in this buffer, and then we set these offsets. So we're basically saying start at position 0 and go for 3 floats. And then now a uint 8 clamped array, and go in this buffer and start at position 12 and go for 4 uints. So this way, we can set things, position and color and so forth. But the real advantage of this is that you can just make one call to your WebGL code to the GPU. Like you're pushing the one array buffer to the GPU as opposed to making 2 separate calls. And so packing data like this wherever it makes sense from a design perspective can really help with performance a lot. And so that was one thing that we just sort of picked up on the fly. JavaScript Scope was just generally a headache. It was it was kind of like the #1 source of bugs during the port. You can use a good JS hint to keep an eye out for this kind of thing. But even then, it was just kind of nasty. We just had to every time there was a bug and it wasn't immediately obvious what the issue was, you kind of had to think in the back of your head, oh, is this a scope issue with one of the variables? Let's take a look at that and investigate. Fault-tolerant loading was a big thing that we had to do. Sometimes HTTP requests fail. And this was the source of a lot of complete black screen bugs, as well as bugs where you'd say, load up the game, and every soldier who went across the screen was a little black square. The solution we ended up going with was a little hacky. We just attempt to load everything, I think 3 times. 3 was an arbitrary number we picked, I guess because it's magical. Break if successful. There's probably a much better way than this, and it would be awesome if there were an XHR attribute for this kind of loading scheme, unless somebody thinks of a better way, and we'll happily do it that way. Recommendation, really, you ought to test on a server that's designed to behave in a faulty, lossy way. You can be lulled into a false sense of security by testing on localhost, or even just testing on a dev server that is awesome because you bought it and you paid money for it and you made sure it was good. You might want to programmatically include latency, maybe up to as much as 500 milliseconds of latency as an upper bound, just to see how long it takes all your assets to load. Even if they load fast on a 1-by-1 basis, if there's a lot of latency, that can increase your loading times dramatically. So basically, you want to simulate a dirty production environment when you're testing these kinds of things. Oops. And finally, this is related to fault-tolerant loading. In many situations, our execution would be dependent on content having loaded. So, for example, if you've just killed your 100th air unit And that means the achievement has to pop up that says you killed your 100th air unit. But if you haven't loaded that achievement yet, well, you don't want a big black box to show up. So essentially, we ended up wrapping a lot of functions that wait for onload events to throw, and we ended up chaining those in the case of menus, where we would need a bunch of different assets for one screen, and we had to be sure that all of them would load. Again, it's common sense, but it wasn't something that we had thought of at the outset that we would really need to do. So then, finally, I just want to talk a little bit about the philosophy of this port. And I think the big dilemma for us, and this relates to what I think all the speakers have been saying, really, which is, do we reach the widest audience possible, or do we create a really high-quality game? What do we do? Can we have both? That sort of thing. To me, I'm sure you're all familiar with this old chestnut, scope, quality, and cost triangle. You can have two. You have to optimize, but you have to, it's a trade-off between all these things. In the case of Fieldrunners, I think it was much more of a sort of, instead of scope of the game, it was more of a browser device audience reach kind of question, and then a question of quality and cost and time. Given, to me, our decision to, launch initially just on Chrome and in Chrome Web Store makes sense, considering that Fieldrunners has, it has a legacy of quality. It's always been a very, very high quality title, and that comes from the DNA of the sort of AAA game developers who worked on it. And we knew we couldn't compromise that. We also couldn't compromise on cost and time, because we knew we had about 2 or 3 months to put this project together. That was just fixed. There wasn't much we could do about it. And so in the end, well, do we get it on other browsers, or do we just create that quality experience on one browser and see what happens? And that's what we ended up doing. That also made sense, though, because there are so many, it already exists in native form on so many other platforms. So we weren't really trying to use HTML5 as a way to deploy to all sorts of devices and platforms from one code base. That wasn't really part of the rationale of the project. The rationale of the project was, we want people to be able to open up their web browser and play Fieldrunners. That's what that came down to. So the takeaway for me from this is that when you're trying to pick your overall strategy, you have to think very, very hard about the browsers and platforms you're targeting, about the audience you're targeting, and how your game and your company are specifically positioned to make the best of the platforms that you end up launching on. So yeah, that's the end of my slideshow. I've got about 10 minutes for a Q&A. And in the meantime, maybe I'll just mute this and we'll just let this run until I die. So, thanks. Questions? You can come on up to the mic, and I'm happy to field them. We got one.
I was just wondering about your choice of using WebGL at all, and was it overkill?
We specifically used WebGL because the original game was written in OpenGL ES2, so we knew that it would be an easy port for the graphics, relatively speaking. I mean, you saw those two slides where the graphics code side by side was essentially unchanged. That was the main rationale. No sense in porting an OpenGL game to Canvas, for example.
But during the course of doing the development, did you feel that it was a better choice also from like performance, or really?
So yeah, we didn't have to do very much performance optimization for this, partly because we were porting the iPad build of the game. It had already been aggressively optimized for the iPad, so running it on a laptop, desktop, it performed great. We did do some optimization, but generally speaking, we were really happy with just how the straight port worked out. And I think it's just because we were going from code that was optimized for mobile to a more beefy desktop, GPU scenario. So.
I guess if you didn't have the original code in OpenGL, would you still choose? Would you have chosen WebGL, or?
That's a really good question. Again, it comes back to sort of my last slide, which is about, it's really all about the context of the specific project you're doing. I mean, if their original game was written in something that wasn't OpenGL, yeah, we certainly would have considered Canvas, and we probably would have spent a few more weeks testing Canvas and WebGL to see where the performance lied, and also new high score. Awesome. Hold on. There we go. Boom. And also looking very closely at the markets as well, right? How many browsers out there have WebGL capability, that sort of thing. So it would have been a more difficult decision, I think. It wouldn't have been just an easy, oh yeah, we have to do WebGL. One of the reasons this project was exciting to us is that there was no business case to be made for not doing WebGL, so we could get away with a really fun WebGL project in a commercial scenario. So.
Great, thanks.
Yeah.
Hi, Darius.
Hi.
How are you?
Good. How are you?
Good. So I guess my question would be, what 3 things did you learn from this, like the big takeaways that you wish you would have known before you started on the project? And then the second sort of follow-up question would be, where do you think we would need to be so that we don't have to compromise so much when it comes to reach versus quality? Like, you know, what are some of the smaller things we can do so there's a medium and we're not having to either compromise one way or the other as much?
Yeah, I'll answer the second question because that's a little bit more direct. I think in order to not have to do that quality versus reach thing, I mean, I think we just need more compliance between browsers over things specifically like audio, right? All the browsers agree on the HTML5 audio tag, but the HTML5 audio tag is not good enough for games. It's good for some games, but you have to really design, your entire sound design has to keep in mind what the HTML5 audio tag can and can't do. For a project like this, which is a straight port, you really either have to go to a Flash fallback, or you have to do Web Audio API. There's other solutions out there too. I bet we could probably have made it work with Audio Data API too. It would be great if everybody had the same standard for super awesome audio, but they don't right now, and so that was a huge stumbling block for us in terms of getting it on all sorts of different desktop browsers. I also think having browsers that auto-update would be, across the board, would be really great too, because that way you can just assume that the user base has the latest version of your browser. That's probably not going to happen anytime soon, so I don't know what more to say about that. In terms of your other question, I tried to put takeaways in the presentation. I wish I had known that hosting and all the server-side stuff would have been as big a pain as it was. I mean, it was a very light application in terms of server-side stuff, right? It was only, the entire server-side flow is like, okay, click here to buy the full game now, and then, oh, I'd already bought the games. It just logged me back in and reloaded the page. But, pop up the in-app purchases thing and then make sure that you have the permissions to access the right content. Not that difficult, but it was actually like the hosting and caching and things like that, and reducing the load times. Fieldrunners is hundreds of megabytes in assets overall. An individual given map, Z, how big's a map in terms of total assets? Yeah. So it's 24 megabytes just to get into the first map, which on a slow connection can take forever. We probably would have pressed more. So right now the HD and SD modes are just scaled just to fit the window. It would have been great if we could have had an SD mode with lower resolution graphics that would download faster. I think that would have been fantastic. So hope that answers your questions.
Thank you.
Yeah, I kind of missed the caching issue. Was that with game assets and your management of bringing it down to the client? Or was it something else?
Yeah, I mean, that was putting in the appropriate headers and making sure things cached for long enough that it was only the first time I load the Grasslands map to play that I download that 24 megabytes of content. And then when I, if I quit out or I quit out of my browser and I go back in, I don't want to re-download those assets. So that's what that was about.
If is audio your biggest wish list item for the next thing the web platform can support equally, and if it isn't, what is?
It is.
It is.
Yeah, awesome synchronous audio. I want Fmod in the browser, more or less. That would make me a very, very happy camper.
Cool.
So, across all browsers, I might add. Any other questions? Nope. All right, well, thank you very much.